Hi everyone. In this video I'm going to go over the two practice problems we had last week. Hopefully at this point you're on board that we're just going to run through these and you're going to look at how they went, if they were successful or if there are some things we need to clean up. So starting with problem one, typical application where we're just looking at two different groups in a larger group. So we have 40 students total. 15 are in IB Biology, 20 are in IB Spanish, 15 are in neither. If this is my universal set, already to start this out, I know how many are in neither. I know there are 15 outside of this set. So let's go ahead and start setting this up. If I have biology here and Spanish here, I'm not even going to worry about this part yet because I need to make the Venn diagram first. So if I know 15 are in biology, don't take the bait and just put 15 here because that's this region and this region combining to be 15. It's not just 15 in bio by themselves. Some of those may be in Spanish as well. We're not sure. So where we start on this is we always work backwards, starting with that 15 being in neither Spanish or biology. So what we do from here is I have 15 students that are outside of that set. So what that leaves me with is 40 minus 15, or that would be 25 students that are in biology, Spanish, or both. So I know these three regions need to total be 25. Well, if I know 20 of these are already in Spanish, I know this set has to add to be 20, while I have 5 remaining in biology, and that is one way we can find out how many are exclusive to biology. Similarly, I can say, well, if 15 are in biology, well, I know 15 are counted here. Well, I could go and work through that this way, or I can recognize, well, I've counted 5 in biology, so there must be 10 that are in Spanish and biology. And if there are 20 in Spanish, we're well on our way now. 20 are in Spanish total. Well, I have 10 counted because this is my set of Spanish. I know there are 10 more that are only in Spanish. So if we walk through this, we have 5 that are only in biology. We have 10 that are in both biology and Spanish, which makes 15 in biology total. Then we have 10 only in Spanish, and 15 of this class are in neither of those courses. So now we can go through and start working on these different probabilities. So if we want to start with B, we want to state the probability that this randomly selected student is in biology. Well, I know 15 of the 40 students are in biology. And if we run through that, 15 over 40 ends up reducing to 3/8, or we can just call that 0.375 is the probability. On to the next one, C. The student is in Spanish and biology. Well, we just need to recognize of the 40 students, how many of these are in Spanish and biology? Well, that's our overlap. That's 10 over 40, or 1/4. So 0.25 would be the probability that I select a student and they are in both of the courses from this class. On to D. The student is in Spanish or biology. Well, what we need to do here is consider the word or. If I'm saying or, they could be in biology, they could be in Spanish, or they could be in both. So we know this is the 25 students are in at least one of the courses, if not both. 25 of the 40 here. And if we reduce this, 25/40 is 0.625, which is 5/8, so 0.625 there. And then finally, the last one, E, is a conditional probability question because it has the word given. So the student is in Spanish given they're in biology. So whenever we see the word given, we're introducing this condition. So if we're given they're in biology, we're only interested in one of the sets, and we're only interested in this set right here. So given the students in biology, so of the 15 students in biology, that's all we're working with right now in our world. Of the 15 students, how many are in biology? Well, 10/15, which is 2/3, or 0.667 there. So the conditional probability isn't that bad actually if you just recognize, well, I'm reducing my sample space. I'm only looking at a subset of the entire population. So there's our first question, dealing with an application. On to the second question. This is more abstract because we're only given different values, probabilities of our sets now. So instead of putting some number like 5 here, we're going to put a probability to represent we're going to put a value between 0 and 1 to represent the probability of that being selected if it were at random. So, like the other one, we have sets A and B this time instead of others. So we want to ultimately find A intersect B, but before that we want to find what this looks like in a Venn diagram. So I know the probability of A is 0.7, but recall that's these two regions. That's the probability of A by itself or A and B. I know B is 0.5, so this whole set needs to add to 0.5. That's why 0.7 plus 0.5 adds to be more than 1, which isn't possible. It's because there's this overlap here that we're counting twice if we add A and B together. And we'll get to that rule actually this week. So we know the probability of A or B is 0.8. So what that tells me is A or B is this region, the overlap, and B by itself. If this is 0.8, the probability of A union B, the probability of A union B complement is 1 minus 0.8, which is 0.2. So I know this is 0.2 here. And from here, we actually didn't really need that, but it's just good to start with it. We'll need it ultimately just to have this Venn diagram complete. If I know the probability of A is 0.7, and I know that the probability of A or B is 0.8, I can find what the probability of A by itself is, because probability of 0.7 is this region plus this region. So if I take 0.8, which is the probability of 1, 2, 3, and I subtract 0.7 from it, that gives me this region right here of B by itself, which is 0.1. So the probability of selecting only B, that got a little wordy there, sorry, is 0.1. Well, if I know the probability of B combined in itself is 0.5, that tells me this is 0.4. And then if the probability of A entire is 0.7, well, I have 0.4 counted already. This must be 0.3. So there we have our Venn diagram complete, and we can just read it now to find the probability of A intersect B, which is the overlap, and that is 0.4. So there we have it. Getting this set up is ultimately the challenge here, and then after that we just read the Venn diagram to get our solution. So there we have it. Both problems worked out. I hope this video helped. We'll see you soon.